All right, got some requests for this paper 2 problem 2015 November. Paper 2 question 5. You're given this function. It's a cubic function. You don't know all the coefficients of the terms, 4 terms, which is the maximum number for a cubic function. And we're looking on a domain from -5, x equals -5 to x equals 7. All right, state whether the function is increasing or decreasing at x equals -3. So you need to start on the x-axis and work your way up. X equals -3 right here. Go up and take a look at the curve. What's happening here? They're asking about the y value. The y value is increasing. Okay, it's going to be a positive gradient until -2. Write down the value of r. Okay, you need to look at the original equation and try and understand what r was. You look at that, it's actually the y-intercept for the short story. You've looked at y equals mx plus c, with c being the y-intercept. For linear functions, you've looked at y equals ax squared plus bx plus c. Again, c is the y-intercept for a quadratic function. Basically, this last constant term is going to be the y-intercept. Okay, y-intercept is when x is equal to 0. So you substitute in x equals 0. The first 3 terms will go to 0, and then you're left with just r, giving you f of 0, which is a y value. So go down here and look on the y-axis, and what do you see for an intercept? 200 there, 100 there, halfway between 100 and 200. The y-intercept is 150. That is r. Next question. The values of p and q are such that we have that for the function. We're going to put that 150 in for r, and then we're going to find the derivative function, f prime of x. Okay, so write out your whole function. You don't know what n is yet. Everything else, you're good, except for, of course, x can be anything from -5 to +7 in our domain. Plus 150. All right, well, the 150 is insignificant because we're going to take the derivative of a constant and it's 0. So go back to the power rule, take the derivative of each term in turn. So again, we're going to take the power rule, we're going to take the 3 down front, multiply it times n, then times x. Then we're going to reduce the exponent by 1, so that's going to be squared. Here you take the next term, you take 2 down front, multiply it times -30, and I reduce the power by 1, so this is just going to be x to the first power. And then finally, this -240 here, the x, the 1 comes down front. Then we take away 1 from 1, x to the 0 is 1, so we're just left with -240. Derivative of a constant, again, is 0. That term goes away. So our derivative is going to be, I said, 3nx squared minus 60x minus 240. Okay. Write down the coordinates of the local minimum point. So you want to look at the curve that was given to you and look for a minimum on the curve. It's local only. The absolute minimum is -infinity. It starts down here at -infinity, then it goes up, then it comes back down, and then it goes up to positive infinity. This is a local minimum down here. So you need to look at the coordinates of that point. X is -4. Y is negative 650. Those are the coordinates of the local minimum. For -650. All right. Okay, question E, you're asked to look at the value of n. So we have a couple of options here. We have a function with f of x, which has 4 terms. We have f prime of x with 3 terms. I'm going to take the 3-term option, which might be simpler. We have to understand that the gradient of the curve instantaneous rate of change is 0 at that minimum there. So our f prime of 4 is actually equal to 0. Okay, nothing to do with -650. So remember your derivative function here, 3nx squared minus 60x minus 240. So E 0 is equal to 3n. I think we said x was 4 there. And minus 60 times 4 minus 240. So the derivative is equal to 0. I could have used the y value in the original function and substituted in -650 for y and x 4, and then work with the 4 terms instead of the 3 terms in f of x. This is f prime of x that I'm working with here. This is f prime of x. Again, the derivative, the gradient, the derivative is equal to 0 at local maximum and minima. All right, so solve this equation and see if we get the value of 10 that we're looking for n. 0 is going to be equal to, this is 1648n minus 240, minus 240. Okay, I get 48n, flip the equation around, is equal to 240 on the other side, so that's twice, that's 480, and I get n is equal to 10, just as I wanted. Next question, F. Calculate f prime of -1. Well, the same way I just found f prime of 4, I can find f prime of -1. Just substitute in -1 into the derivative function. All right, so what that's basically asking, what is the gradient at f equals -1? We just found the gradient at x equals 4 as 0. Now we're going to look at the gradient f equals -1. So you go 30. Now we know what n is. 30 times -1 squared for x minus 60 times -1 and minus 240. Okay, do a quick calculation on that, and we get f prime of -1 is equal to 30 plus 60 is 90, minus 240, that's -150. So that's a gradient of -150 at f equals -1. Go back and look at the curve, see if that makes sense. F equals -1. The slope is going downward here, okay, downward. And then if we looked at the actual gradient and really tight here, we might see that it's down -150 for every x. Step to the right. Rise over run. Okay, that's F I. Now we got to look at double I. Find the equation of the tangent to the graph. at -1, 350. Well, they're pretty nice. They told us what y was at x equals -1. Again, you can go back to the curve and see that here x equals -1, y is equal to positive 350. So we can use those values and the gradient to find the equation of the line. Okay, that's I is to find the equation of the line, and they want us to write it in standard form, just for good measure. Okay, so I'm going to start with y equals mx plus c. That's what I know best. So I, y equals mx plus c. Well, y we said was 350, m -150 from above, x -1, and c. We don't know what c is, okay, which is the y-intercept of the tangent line. So again, I get 150 over here, 350 on the right, on the left, actually, and I'm going to flip the equation. C is equal to 200. Okay, but that didn't answer the question because the question wants it in standard form. So I have to write y equals mx plus c. (150x plus 200), and I have to move everything to the other side of the equation. Get a 0 on the right-hand side. So this is the answer I hope that they're looking for. And then finally, triple I, excuse me. You want to write down the gradient of the normal line, normal to the graph at x equals -1. Well, the normal is the inverse reciprocal of the gradient. Actually, this is the gradient, never -150. So to find the normal gradient, we're just going to do -1 over that gradient. -1. So the perpendicular, or however you want to say, the normal line is going to be -1 over -150. Okay, so that is our perpendicular slope from straight line graphs, perpendicular to the original gradient. Okay, they're not asking for the equation of the gradient or of the normal line, but of course they could. All right, last couple questions here. We're asked to use graphic display calculator to find the x-coordinate of p, and then we're going to use a graphic display calculator to find values where we have this straight line intersecting the cubic function f of x in the given domain, which I've already set up my calculator for that. You can look over here. I want to set up the window size for the given function. And again, they said -5 to +7 for x up there. So I set up the x values, -5 to +7. And then I look at the graph over here and I see that their maximum is 700 and the minimum is -700. So I use those in my calculator so I can have a picture that looks very similar to the graph given to us. All right, and they're asking for the x-intercept. There's 3 of them, but they only want the x-intercept p. Okay, so it's going to be 6 point something. So we're out here on the third x-intercept. So go to the function. Remember that originally we solved for, we proved that n is equal to 10. So when you plot the function, excuse me, and put the function to your calculator, we're going to put a 10 in for n right here. So it's 10x cubed minus 30x squared minus 240x plus 150. Okay, So that's what I'm showing on my calculator. Look at the graph. It should look very similar to the graph given. You can confirm the minimum and maxima if you wish. And we only need to know this x-intercept over on the right. So go to trace, the second calc, try for a 0. Okay, and I want to be close to that 0, and I want to have a sign change on y from negative to positive or positive to negative. I'm going to start with the left bound y negative, hit enter, move to the right a little bit so that there's a sign change. Here is y is positive, enter, and then I'm looking for a sign change somewhere in between those two values. And the calculator will do the trial and improvement for me. And I get, this is 1 to the times 10 to the minus 10, which is virtually 0 for y. That's our x-intercept. Rounded to 3 significant figures, 6.39. Okay. The other question was to look at the x-coordinate of P, 6.39. Getting a little messy here. And H, put in this other function, 100x plus 400, and find the intercepts. So I'm going to put that in y2, 100x plus 400. Go back to the graph. And we see a couple of intercepts. We don't see the third one way up high. Okay. Is it in the given domain? Might have to do a zoom fit to see if it is. Could be a trick question. Anyway, we see a couple of x-intercepts here. Let's get those real quickly. 3 of them. Find the values of x where f of x and g of x are equal. So second trace, intersect this time. And then it'll tell you the first curve is our cubic. Maybe I want to trace over to the first intersection first. So I can just hit enter really quickly and get all 3. Okay, first curve is the cubic, second curve is the linear function, y2. And then I'm looking for a guess somewhere close to that x value, and I get an intersection of negative 3.97. Negative 3.97 is rounded to 3 significant figures. Okay, that's for H. Really messy. Okay, and there's 2 other intersections at least. Okay, so again, second trace, intersect, and I think I want to scroll over closer to the intersection that I want, and then hit enter 3 times, and I get the other intersection. Rounded to 3 significant figures, negative 0.809. All right, now this third one that's up off the screen, we could zoom out and take a look at it, or do zoom fit or something, or change the y coordinate in our window. Look up to max, I don't know, 3000. And I'm still looking to see if that's in my X window size, this third intersection. So there's my cubic, and looks like the third intersection is off the screen. Okay, so it's out of our domain. I'm not concerned with the third intersection. End of the problem.